Oh, thank you, Sarah. All right, our final presentation for the session is from Ping Lu, who is the lead for ecosystem restoration at ERA and has been working at Ranger for many years now. Ping will be presenting on the title of Ping's presentation is From a Waste Rock Landform to a Vibrant Ecosystem. Lessons learned from a 12-year-long trial at the Ranger uranium mine. And Ping, you've got quite a bit of time, mate. So there you go. Please welcome Ping.
Good afternoon. Yes, first I would like to acknowledge my co-author Aidan Wright here and Megan Parry, and also the work is accumulative of all the efforts of past colleagues as well. So we have one actually past colleague here, Anja Zimmerman, just over there. Thank you. Oh, yeah. And I would like also acknowledge our traditional owner Mira people of our mining site and also our local here in Darwin area people as well. And as you can see here, are the visitors to the trial landform that I will talk about today. First, I would like to quickly recapture what's the requirement for us to do, what's the task for us. Actually, we have about 950 hectares of the areas need to be rehabilitated before 2026, January 2026. And of which we have 760 hectares are West Rock fallow landform, basically the landform covered with West Rock. And then the rest is 190 hectares of natural bush, which has been irrigated with effluent water, it's just runoff water. We need to have more than 1.2 million trees need to be planted, tree and shrub need to be planted. So the question today I will discuss with you is, can West Rock only substrate support a sustainable ecosystem? So as you can see here, that's the disturbed area that will be covered on West Rock, and then those are irrigation areas. And my presented work will be all concerning here. It's a trial landform. So the West Rock landform, we need to examine it first. What is the properties of the West Rock landform looks like? This is that natural soil. The Ranger fallow landform will be constructed with West Rock. The West Rock substrate is significantly different from the local substrate. As you can see on your left-hand side are West Rocks. And then this is soil naturally developed of the bedrock, whatever, over a million years. So you have more fines at the surface, which is a soil profile, and then you have those fricate, which is most of the times impenetrable to the root system, but there are some macro holes as well occasionally in the soil. But most of the root system is in the top 30 to 50 centimeters. But in the West Rock reconstruct landform is basically you have the same particles distributions from the top to the bottom, let's say 4 or 6 meters. They're all fractured and their fines, just move on. Their fines is actually much less in the trial landform. It's about 20 to 30%. Compared to the natural system, you will have the top half meter to 2 meters is have more than 50% of the fines. The fines actually is anything smaller than diameter is smaller than 2 millimeters, which actually holding water. So, and also, if we have a close rock of this chemical and biological properties of the West Rock property, you can see the West Rock substrate have 0% of organic matters compared to 0.5 for the analog site or reference site. And because the rock for the trial landform construction was come from the blasted, just a freshly blasted West Rock from the pit stream, so they don't have any microbes or useful or beneficial microbes population in the West Rock, and also the total nitrogen, which is also it's about 1/10 of the natural system, and mostly it's come from the blast dynamics. So as I said, the profile, sorry, the soil profile, the substrate profile is fully fractured. Basically means if you have any water penetrate from the top to the bottom, it just runs through the system. So it doesn't really, if it's not designed properly, it's just the water just runs through the system. It's like sieve. That's the trial landform looks like. The one I will talk about. And so the footprint is about 8 hectares and try on West Rock, and it was constructed end of 2008 and completed by March 2009. And we have planted more than 11,000 trees. There are the plants of 40 local native species. Yes, just very quickly about this design of the landform, trial landform. It actually was trying different revegetation methods like tube stock planting or direct seeding on different substrate, West Rock only, or West Rock with mix of with laterite, some fine material, weather material. But today I will focus only on this one, it's tube stock planting on the West Rock only. So why? That because our study has demonstrated that direct seeding on West Rock is not viable options. If you have any questions, welcome to discuss with me later on. And also we have been told actually Ranger don't have any fine material or weather material available to mix into the West Rock. So now I only talk about the realistic options we have. It's West Rock we have and using tube stock. The trial landform, as I said, it was revegetation was done in March 2009. By now it's about 12 years now, 12 years out. So far, how much fertilizer we have used? At less than 150 grams in total for each tree, 150 grams. And the irrigation ever has been run only for less than or up to 6 months, so never more than that. And yesterday when we were at the Darwin Easter Point revegetation area, they're talking about irrigation for 2 years. And actually that was on soil. Let's very quickly give you the history of the development of the trial landform. And 2010, April, at 1 year after, you basically still you still don't see much about at all after 1 year of revegetation on the final landform on the trial landform. It's just the West Rock still, okay. And about 6 years later, you will see already tree appreciable from the air plant, from this one, from actually helicopter. You can see them already, that's the West Rock only, using tube stocks. And this is surrounding ruminant vegetation. Yeah, 10 years old revegetation looks like, and then my colleague Aidan Wright and also Meg was working in the bush, not bush, actually, vegetation on the trial landform. The same year during the wet season, that was dry season, and then this same year in the wet season, or beginning of wet season. So you can see that it's really vibrant. You know, the vegetation is large, great after wet season. And it's the tree that went more than 10 meters high in front of the plot. And last year, when we did the last survey, was 11 years after the revegetation. And out of the 40 species we used for the revegetation, the 37 tree species had the overstory and midstory species have flowered and fruited. As you can see here, is all the nice pictures of flowers and fruit we had. And also, almost 3/4 of the species have self-recruited either via seed or by vegetative reproductions. And here I'm showing one of the green plum, Bucania, and which diameters before was worked on by the termite. It was about 15 centimeters diameters of green plum tree, and it was very, very productive. They have two trees nearby to each other, about 2 meters apart or 3 meters apart. Both are very productive in terms of green plants, and we have the thousands, several kilograms for the radioactive residues studies. As you can see, the tree has been worked on by a termite and then disappeared within 2 years or 3 years. And now that basically reduced to just the soil, as you can see. And what is very interesting is that we have hundreds of those young seedlings come from the seeds that was dropped on the ground and survived through several dry seasons. And also you can see that Acacia and the Grevilleas was recruiting in the vegetation sections of the West Rock. And we have also animal colonization that Sarah talking about. Yes, yeah, you can see some of the very high levels, such as snakes, which need food there so they can survive. Oh, now I'm talking about the lessons or anything I can share with you and the key lessons with you. And since the visitors come, especially not really biologists or ecologists, they come to my site, they said, Ping, I see a lot of dead trees in your sections. It's not very good. More dead trees here. I said, no, actually, there was a program, programmed the death of those trees. They are acacias. Okay, so the first learning is actually we need wisely to use the acacias in our revegetation, especially considering when we don't have topsoil. We only have West Rock without any organic matters or with a minimum or near zero contents of the nitrogen, and also not much water holding capacities in the top layer of the substrate. In that case, really you need to have a starter of the ecosystem of soil formations. Basically, we need to use the acacias. They are perfect. They are nitrogen fixing. They are short-lived. You know, that doesn't short-lived, and so they can basically prepare the soil for the slow-growing species or long-lived species such as eucalyptus or terminalias or other species. Now here is the two species we use. The one is Hemineosta, and another one is latescens. But we have actually used for the trial landform, about 20% of acacias mixed in the all the species we have used for the stems, sorry, for the trial landform. And they are actually the local native, long aggressive, short-lived acacias. They are Acacia dimidiata, Leminosta, latescens, and also Mimla. That to kick off the soil formation because there's no soil, nothing. And a decade later, soil is forming. We have, thanks to the Professor Rongbing Huang here, and he did two actually studies on the soil formations and the nutrient cycling at the same site. So as you can see, the dead acacias are turning into the nice soil. Okay, it's harder to, it's because the senescence or death of the trees of acacias started about 5 years after the revegetation. And there was a lot of standing trees, dead trees. Now it's very hard to find trees I can take photos because it's all walked away wasted off by the termite and other borrows. So it's very hard to find some good stem on the ground. So that's very nice when you can see the soil is forming from those acacias. Yes, and also the fungus is working on the litters and also debris as well. Yes, because as I said, the many of acacias now, I don't have a photo or I haven't found my photos, is if you have a overhead shot, you will see initially about 5 years time, the vegetation looks very nice. There's a lot of green acacias mixing with other species. Now you will see not many acacias there anymore. So I'm a bit worried that the ecosystem might run out of nitrogen or organic matters quickly. So with the help of Rongbing, actually, he pointed out to us that we need to have understories because understory stories actually have better quality, the high quality of the organic matters for the microbial population to use. So then Meg would join my team to introduce the understories, especially the legumes, the legume understories into the trial landform. We have a quite good success thanks to Meg and the CDU team. And also, as Meg already mentioned that, in the first 8 or 9 years, basically, we don't have many natural recruitment. But last year or the year before, we have certainly have a surge in terms of the natural colonizations of external resources, external species, which was not used in the revegetation at the trial landform. Just remember, trial landform is about 4 meters above the natural background. So it's actually have steep slope and also the rock only face for the animals can climb onto the trial landform. So it's got some difficulties for the animals move up. So we have a surge of that one. As Meg already explained that this is reflections of the west rock substrate has been now have a soil forming. So we have now leaf litters. We have more food or resources to be used by other animals, other fauna to use. So when the animals come to use resources, they bring in with their food or whatever, bring all their food and come out, and it's actually bring more seeds to the trial landform. So that's why this external the natural colonization happens on the trial landform. So basically, this comes to my next key learnings is we need to value the natural process. Basically, we as the ecological restorers, whatever, restoration ecologists, what do? We actually create a framework according to our traditional owner, Yvonne says, we need to have a good house, welcoming house for animals coming in. They were like humans. When we like your revegetation, then animals also love it. They will colonize. They'll use your vegetation. So that's exactly what I see is we need to value that process, natural process. Okay, you leave to the mother natural to actually to help you to complete your revegetation or ecosystem restoration task. As Meg pointed out, here is a picture showing it's only 1.1 hectare, 1 square meters areas. We have 5 different species there, Meg? At least 5, and different species which we haven't used in the revegetation come from outside. And Meg has did the surveys because we regularly do monthly survey of their usually. And as we find at least 38 native species has been discovered on the trial landform, and the majority of them are understorey. Okay, I basically finished, and then just quickly show you what is the next step. We are continuing to monitoring the trial landform and further introduce the secondary species and understorey species. And we have already started this year, just last month, 45 days ago, and we finished the 6 hectares of the pit 1 final landform, and we have more than 700 hectares to be revegetated between now and January 2026. So you will see a lot of information from our mine closure plan, which is available online. And also welcome to talk to Meg and Aidan and myself near our booth over there. So thank you.
Thank you very much, Ping. We do have time for a few questions before the afternoon tea break, if there are any.
Hi, Ping. Thanks for the trial landform update. Just going back to the rates of natural recruitment onto the trial landform, and there was obviously some upwards and downwards trajectories on the plot 1A. Besides soil formation, do you have any understanding of what could drive that? Like, I'm thinking like possible, like the quality of the wet season before that, or the length of the dry season, and possibly other fruiting and flowering events of the species on the trial landform that brings in other fauna. So just get your thoughts on that.
Yes, as you know that our species is basically is all the major species in the surrounding areas already used in our revegetation for the trial landform. So the many are fruit-bearing trees. They got fruits. So the animals, the frequentations of animals come to the site, and also some other animals is using the habitat, actually using the leaf litters, maybe to get find the invertebrate in the invertebrate, or some worms in the litters to use that resources. That's why I'm saying in the first 8 to 10 years, it's not many. Although we have observed that animal fauna are visiting the site, but probably it's not as to the frequency that's high enough to trigger, really bringing a lot of species. And also they have time delays as well. From the time the seeds was coming to the landform and then till the time we can see them come out. So I think that after 8 or 10 years, that's the time we will really see them coming up. Does that answer your questions?
I'll hand you the mic.
I'm not sure of what you're asking, Jay, but exactly. But with the graph that was shown over time, because it's a monthly survey, and a lot of those recruited understorey species, a lot of them are annuals, so you tend to get a big fluctuation towards the end of the wet season, and then it'll drop down. So it's just a monthly observational survey, so it'll drop down over the dry seasons. There's less diversity over the dry season.
Yes, some of those recruit actually they cannot survive through the dry season. But some species, as I said, the green plants, typical, they survive through. Like,
And also building on some of those things you're talking about. So where we're seeing lots of these little pockets of higher species richness, is we're often seeing these under either big canopy trees. So like eucalypt trees that seem to be sourced from, we imagine, fauna using, sitting in that canopy and then delivering their goods and finding a nice home underneath. So we're seeing lots of little pockets of species rich areas, which we believe have come in from birds or fauna. And as well, what we're seeing, we've started doing these monthly surveys since September 2018. We're still doing them now. So there's actually another year's worth of data on top of this. And what is really interesting is that we have had different types of wet seasons during those times. And although we're seeing similar perennial species come in, there is quite a bit of difference between the annual species that we're seeing. So seasonal differences, the species that the plants that are actually being used, all of those things we do think do play a part in what we're seeing in terms of species recruitment and colonization.
thank you. Longbing.
It's very exciting to see the understorey species. I think all those pockets of understorey species recruitment, is it more to do with coinciding with the concaving patches, which has got organic matter and fines? Have a look at if that's pattern. My speculation would be those are very critical to maintain the moisture for the seed germination. I think with the more organic matter weathering fine, you see more and more those colonies, islands start to pop up.
Thank you, Longbing.
Any further questions? Over here?
A bit of a devil's advocate question. There's a really interesting poster out there for all of us to look at afternoon tea. It talks about the cost, how much has been spent at Ranger in 2020. There's an amount of seed collected, a number of plants planted. Do you have any sense of how much it's costing per surviving plant?
The cost for revegetation for each plant. Okay. The cost for the trial Landform planting is cost about $2 each in terms of we buy from the crystal, the Kakadu native plant, and the price has since revised and is increasing now. So probably around it depends on quantity, how much we have. In the USA, it's $3 or $4, something like that. You average out, and then you will have the cost for plant them. So it's all add up in our revegetation plan. I think it was yeah, yes, but it's in terms of the whole big pictures as a case, as I mentioned, the whole rehabilitation cost of course $1 billion. Is that right? Case? Yeah. He's doing like that. Okay. So let's say $1 billion, and the revegetation components is quite small. And even with that small components, is the irrigation is a big component of that. So the actual revegetation is still a small component of it. And big component for the whole rehabilitation is a bulk movement, basically backfilling of the pit, and also the water treatment. That will be very challenging.
All right, thank you, Ping.
Thank you.
That probably brings us to time. So thank you for that presentation. That was great.